Everyone, in this video, let's take a look at question 638, shopping offers on Leetcode. This is part of our blind 75 list of questions, so let's begin. So in this question, I'm actually just going to go through the examples because the description is very bad, so we'll just be understanding from the examples. So let me paste them in here. Okay, so basically in this problem, we are going shopping and we have access to three variables or three lists. We have the price array, the special array, and the needs array. The needs array basically says we need 3 apples and 2 bananas. The price array says that 1 apple costs $2, 1 banana costs $5. What we want to do in this question is we basically want to figure out what is the minimum cost that we can pay to fulfill what we need. So what is the minimum cost in which I can get 3 apples and 2 bananas? Well, one way we could do that is simply by buying them outright, right? So one thing you could do is that for 3 apples, you could pay $2 each, so that's $6 for the apples. And then for 2 bananas, you can pay $5 each, so that is $10. So that is $16 altogether. So this is one answer. But this is actually not the best one. The best one, we have to use something called special. So this is kind of like your, you can think of it as like a discount or something like that. And it applies with like grouped items together. So what this means is that for $5, you can get 3 apples and you can get 0 bananas. For $10, you can get 1 apple or 2 bananas. Actually, 1 apple and 2 bananas. So this is like and, right? So these are the special offers. So what we want to do is we want to think of an algorithm so that we can either use the special offer or the prices, and we want to basically arrive at the minimum answer. So now, what is actually the answer in this case? Well, initially, we need 3 apples and we need 2 bananas, right? So in this case, basically what we can do is we can use special offer number 2. In number 2, we get 1 apple, we get 2 bananas. So 1 apple means this is now 2 apples left. 2 bananas means this is 0 bananas left, and we pay $10 for this. Now we need 2 apples, right? For 2 apples, well, we can't actually just use the special offer again. And the reason for this is actually twofold. First of all, it would just be way too expensive, right? Like this is not the correct way of doing it, because then you'll be paying $20. But the other way is you notice that this one, it gives us 2 bananas, right? But we don't need any more bananas. We need only 0 bananas. So your needs need to match exactly. You cannot get more than you need. Your needs need to match exactly. So that's another reason why we cannot use this. Even if this was something like, even if this was something like if this was a 3, right? Then the apple is more. And if this was something like a 0, the apple is more than what's required. So it still won't work. So one thing we will do is we will use this special offer, and then what we can do is we have apples remaining, so we will then just pay for the apples. So it looks like we need, the apples cost $2, right? So we will need 2 more apples, which will cost us $4 more. And this one will give us a total of $14. And this actually turns out to be the minimum cost. So it's like a similar thing over here. Basically, you don't have to use a special offer, but in this question, you should check to see if you can use a special offer or not. So how might we go about doing this question? Well, one thing we already know, right, is if we don't have any special offers, then our possible answer, at the worst, right, at the worst, our possible answer should be the needs array times the prices array, right? So in this case, the worst answer should be this, right? Assuming we don't be stupid and use specials twice and it costs us even more than the original one. So this is possibly the worst answer that we would want to return, right? But otherwise, how can I solve this question? So if you think about it this way, let's say my needs array, initially it is something like this, right? A is equal to 3, so I need 3 apples and I need 2 bananas. Now, let's say I use this special offer. Let's say I use this second special offer here. So in this case, I have paid $10 and I have used 1 apple. So I've got 1 apple, so now I need 2 more. And I've got 2 bananas, so now I need 0 more. Now, basically, I need to figure out what is the best, or what is the minimum way I can get 2 apples and no bananas. So this in itself, if you think about it, is its own problem, right? And the way we can kind of solve this is we had an original problem, right? 3 and 2, and now we have a smaller problem, 2 and 0, right? So one way you can think about doing this is recursion, right? Why don't we just treat this as its own problem and just call the method again, and then from this we can find the minimum price to get 2 apples and 0 bananas, and maybe that one will result as whatever it's going to return. We don't know what it's going to return, but we can basically like work our way downwards like that. So think of it like that, right? Like if you have a bigger problem here, and then maybe we use a special offer, and then we arrive at a smaller problem, and we want a way to figure out what the answer to this smaller problem is, right? And maybe in that one, like we have no special offer, and all we have to use is like the price. Like maybe we have to return the worst answer, but so be it, right? So, but the point is like we have one problem, and then like we have a smaller one that we can just treat as its own problem, and then do a recursive approach like that. So let's maybe take a look at how we can like make this happen. So in this one, like we're doing like a generic recursive type function. So what I'm just gonna do is I'll just return my function here, which I will call helper. And basically helper should return to me like the minimum cost, right? The minimum price that I'm expected to pay. So I'll pass in price, I'll pass in special, and I'll pass in needs, right? Okay, so we have this information here. Now, first of all, what I need to do is I need to define my helper. So I will go self, price, special, and needs. Okay, so first thing, so what is like the worst answer that I could potentially return, right? So the worst answer that I would want is like if I don't use any special answer at all, right? Like if I don't use any specials at all, if I just use the existing needs and just the prices that are in the store. So one thing that we could do here is I could do answer and I can set as 0, and then I'll actually go through the needs array, length of needs, and then I could do answer plus equal needs of I times price at I, right? So this is like the worst answer. And in the very end, what I want to do is I want to return this answer, but actually like in the middle, we will calculate to see if there is a better answer through our recursive call. So let's see if we can do this. Okay, so here we are not using any of the special, right? Like we are just using the price and the needs on its own. But now let's see if we can use a special. So I can do something like for special, or I can do like for offer in special, right? In special, something like this. So what can I do here? Well, one thing I could do here is I need to first of all figure out whether or not this special is even valid, right? Because as we discussed earlier, you need to have the exact amount, or you need to have a little bit less offered by your special. You cannot have more offered by your special. If you have something like this, then it's not going to work. This is not allowed. So we need to somehow check this. So what can we do? So let's say we have a valid flag, and initially it's true. And then what we could do is we could maybe go through our special. So we will just cycle through needs. So here needs, like maybe needs is something like 3 and 2, think of it, right? So now what do I need to do? Well, I need to basically check like I need 3 apples, right? I need to make sure that this special is giving me 3 apples or less. I want to make sure it doesn't give me 4 apples. If it gives me 4 apples potentially, then it's false, right? Like we cannot support this. So one thing I could check is I could basically check if needs at I, if this is less than, like if the offer is giving me more offer at I, right? If this is case, then valid is false, right? This is not a valid one. And then so we can actually break. We don't even need to look at the rest of them. So by the time we reach here, either the offer is valid or it's not valid. We don't know. So what we can do is we can check. So if it is valid, then what? Well, if it is valid, then now I have like, now I'm going to use this offer. And so I need to update like my needs, right? Because once I use this, like let's say I use the second one, needs goes from 3 to 2 to what? It goes from 2 to 0. And so then this is a problem in its own. So I can update my needs, and really what I'm going to do here is I'm going to create a copy of needs. I don't want to do like needs and then like just update needs altogether, because it's possible that like in the next special, um, like we need to use needs again, and so it should be the original one. It shouldn't be the one that was like modified in like the first special, right? So we need to create a copy here. So we'll do something like needs copy, and then I'll create a copy here like this. And then what I can do is, well, I can calculate the price of like this special, right? So I can do like offer price, and we know that the offer price is like this last element here. So that's like offer at -1, right? The last element here. And now we need to update our needs copy array, right? So from 3 to 2, we basically need to subtract out what is given in the special. So I can do something like for I in range, length of, well, I guess here it would be length of needs, right? Or needs copy, since it's the same thing, let's just keep it needs copy. Okay, so what are we doing? Needs copy at I, what should it be? Well, it should be minus equals. It should be whatever needs copy of I is minus whatever offer at I is, right? So if needs is, if we're given 3 apples here and special offer gives us 1 apple, well, now we need 2 more apples like that. Okay, so now we've updated our needs copy. So now what can we do? Well, after this is done, Now we have a new need copy, right? Now we have something like this. Now we have a new problem. So basically, I want to figure out the solution to this problem. What is the way that I can figure out like the minimum price of this? So why don't I just do a recursive call here, right? And what should I pass in? Well, I want to pass in what's given. So price. I want to pass in special. For needs, I want to pass in needs copy, right? So I need to pass in the copy here. Now this will give me a price, right? This will give me how the minimum price it takes to calculate this set, which is like this thing here, the 2 and 1. But notice how this one does not include like the price of actually using this offer in the first place. So we actually need to add to this offer price. So the cost of calculating like the cost of 2 and 0 will be whatever the price of the offer is, price of the special, plus the cost of then like calculating the 2 and the 0. So this is what we get. So this is like a potential different answer. So this we can call it like special. Maybe not special. We can call it like what do we want to call it? I don't know, like with special, right? Like with special. Okay. So now what do we have? Well, now we have the minimum cost using a special. Here we have the minimum cost without a special. So I want to basically return. What do I want to return? Well, I want to return the answer such that it is the minimum. It is the minimum of whether the existing time we use a special or existing time we don't use a special or we use a special over here. So what I can do is I can do answer is equal to minimum of answer and then with special. So answer here is like without special. Here it is with special. So that's basically like what I'm doing. And then this is all really there is to the problem. So if I go ahead and run my example test cases, and it looks like I have a bug somewhere right here. So let me go ahead and run my example test cases now. Okay, it works. Let me try to go and submit it. And perfect. So you can see like this works, but like we're getting like a TLE, right? Now, this solution actually used to work like in 2021. But it doesn't work now, and it's because they added in like this super long test case. So the way to kind of go around this, like our approach is still correct. The way to go around this is, as with any recursion, you can make it faster by using a little bit of memoization. So we just cache our results. So again, the way we create our memo is we pass in a memo, or memo is actually like a dictionary, a mapping. Here it'll be a memo. Here we will pass in the memo, right? Anytime we do a recursive call, we pass in the memo. Now, what do we need to store in the memo? Well, what is changing, right? So price is the same, special is the same. Needs is the one that changes, right? Needs copy changes. So we need to basically cache this array here, like the cache array of like what we need. So in order for us to actually do this, we need to convert this to a tuple because you cannot like add in a list into a dictionary. So what we can do is we can actually just check at the very start. Maybe we can just call this key. Let's just call it key, and we will call it a tuple of needs, right? And what we can check is if key in memo, then we will just return memo at key, right? Similarly, at the very bottom here, before we return answer, we will just do memo at key is equal to answer, and then we can just return memo at key. And then here, when we are doing this recursive call here, we will store this. We will store this call, actually this call, in the memo, right? So we need to store this as well. And actually, now that I think about it, we don't need to store this because yeah, because it's returning like down here, right? So we actually don't need to do anything here. Because if this is potentially in the memo, then it will get like a hit over here. So then we don't have to do anything about it. So let's go ahead and run these test cases here. And then I'll actually open this on the side. So let me go ahead and see what this test case is. I will paste this in. And with any luck, we'll get the answer. Okay, cool. And so now let's go ahead and click submit. And perfect. So this is how we do the question. So basically, like what we did is like we understood that like our question could be broken down into a different question, and we could basically just do a recursive call to solve this recursive question. And so that's how we did it. Now the time complexity for this one, it's really honestly it's a little bit difficult to analyze simply because like when you have recursion, then it's a little bit difficult to analyze like that. So you can check the discuss, or you can also just check the solution to understand the time and space complexity a little bit better. Okay, thank you for watching.